Hello everyone. In this sequel of the video, we will be looking into what pivot variables are for a matrix, and we'll be finding that, or rather verifying that the number of pivots in a matrix is actually the rank of the same matrix. Okay. If you remember in the previous sequel of this series, we had actually derived the row-reduced form of a given matrix, which was this. This was actually the row-reduced form. According to the three given conditions, we were satisfying all of them, so this actually was the row-reduced form of the given matrix A. So, what are pivot variables? Pivot variables are generally the leading non-zero entry of any row. If you see in the first row, 3 is the non-zero leading entry, and in the second row, 1.6667 is the non-zero leading entry, and in the third row, there are no non-zero leading entries. So what are the number of total non-zero leading entries? It's 2, because it's 3 over here in the first row. The first row, the leading non-zero entry is 3, and in the second row the leading non-zero entry is 1.6667, so that makes it 2. So the number of pivot variables in this given matrix is 2. Now what about the rank of a matrix? Rank is defined as rank of a matrix is the maximum number of linearly independent rows in it, or in other words, or in rather in much simpler terms, it's the same as the number of pivots in its row reduced form. So the pivot variables have to be identified first, and then they have to be counted, and that would actually give you the resultant rank of a matrix. That's what it says, at least the definition. So for finding the rank of the given matrix A, we will be counting the number of pivot variables, and that would give you the rank of a matrix. So here in the first row, 3 is a pivot variable, and in the second row, 1.6667 is the pivot variable. So the total number of pivot variables are 2. So the total number of pivot variables being 2, let's find the rank of a matrix. And the command for finding the rank of a matrix is rank of A. Remember that I've told you that Matlab is much easier to actually work with matrices because it has a lot of predefined functions like rank, which would give you the result in a single statement. So answer is 2, which makes the rank of the given matrix A 2, and 2 is also the number of pivot variables. Referring to it again, please remember that pivot variables are the leading non-zero entries of any row, which are 3 and 1.6667 in this case. And also note that in the third row there are no pivot variables because all of the variables, or rather all of the elements in the third row, are 0, and for a pivot variable it has to be a non-zero entity, and also the leading term. So simply the rank of the given matrix is 2, and that is also the number of pivot variables, hence verified. Thank you.